Okay, so let's talk about solving and graphing absolute value inequalities. So here is a little bit of a cheat sheet that I have for you guys. You might want to take a picture of this, print this out, write this down, whatever you do, so you can use it when you do your problems. But ultimately, you should want to memorize these or understand them so you can do them without looking at it. Okay? The way I remember it is that the top two is less than, right? Less than means and the bottom two is greater, is or. You know how it rhymes? Less than is and, but greater is or. Okay, so or means you split them up and they point away from each other, this or that. Whereas the less than is and, means they're together, this and that. So they come in together, and. Okay, so that's the way to remember it. So I'm going to show you what I mean when I do an example. I have absolute value of 7 minus x is less than or equal to 4. Okay, so this is this case right here, the second one, where you have less than or equal to. Okay, so that c is basically that 4. So I set up by taking that number and making it negative 4, and then you have the same symbol there on that side, less than, and then you have just this expression in the middle. So 7 minus x less than or equal to positive 4. All right, so here I want to subtract the 7 from all three sides, right? So subtract 7 from all three sides. I have negative 11 less than or equal to negative x is less than or equal to negative 3. But this is negative x, so I have to divide by negative 1 to get it become to a positive x. But when I divide, remember inequalities, when you divide or multiply by a negative number, you have to flip your inequality. So it becomes like this. Positive 11, and now it's positive 3. So here you see how my inequalities are kind of flipped, so it looks weird. I'm going to have to move it backwards. So 3 is less than or equal to x is less than or equal to 11. All right, so I just graph that. I have 3 and I have 11. Now, because it has an equal sign, right? That means my dots are solid. If it doesn't have, see, there's an equal sign here, so my dots are solid. If there's no equal sign, my dots are open, like hollow dots. Anyway, so they come in together because it's less than. All right. If it's greater than, it would have pointed out. Okay. Example 2. I have 4x plus 5 is larger than 13. All right, so this is greater, it's or, so you have to split into two different ones. See, it's this case right here, greater, two of them, or. So you keep the original, 4x plus 5 is larger than 13, and then you make the second one negative. So you have 4x plus 5, and then you have negative 13, but when you do the negative, you have to flip your inequality, so it's this way. All right, so you solve for that. Subtract 5, 4x is larger than 8. Oh, my computer is lagging. All right, so you divide it by 4. X is larger than 2. Here you subtract 5. 4x is less than negative 18 divided by 4. X is less than why did I do that? Negative 9/2. Okay, so I graph that. So look, I have one at 2 and one at negative 9/2. So x is larger than 2, you know. So, oh, by the way, there's no equal sign, so I should have a hollow dot. But x is larger than 2, so I point out. Right? And x is less than negative 9, so I point this way. Less than, so I go to the left. But you see how we started out with greater than, so they point away from each other? That's the case here. Right? Because it's greater than, so they point out. Open dot because there's no equal sign. There's no equal sign here. Let's do example number 3. I have 2x plus 1 less than or equal to 9. Alright, so less than means it's going to be together. Alright, less than is and, so they point in. Alright, so they stay together. So I have negative 9 less than or equal to 2x plus 1 less than or equal to 9. Alright, so you keep the same in the middle, and you have a negative of that number on this side, positive on this side. And then subtract 1. Negative 10 less than or equal to 2x less than or equal to 8. And divided by 2. I have negative 5 is less than or equal to x is less than or equal to 4. Then I draw my graph. And here's negative 5. Here is 4. There are equal signs here, right? So you put solid dot. You color it in, shade it in, and they point inward. That means x can be any number in between negative 5 and 4. X can be negative 3. X can be 0, x can be 1, x can be any of these numbers. Any of these numbers will work for x. Okay, x is between these two numbers. Last example. I have x plus 2 is larger than 6. Greater than means means or, right? So I have to split them into 2. So let's make this equal to. Alright, so split this into 2. I keep the original x plus 2 is larger than or equal to 6. And then I make the other one x plus 2, and I flip the inequality and I make it negative 6. Alright, then I just subtract 2. X is larger than or equal to 4. This one gives me x is less than or equal to negative 8. So I make my number line. Here is negative 8. Here is 4. There are equal signs, so you color it in solid. Solid. And because it's or, they point out, right? So it's larger than negative 4, you point to the right. Less than negative 8, so you point to the left. Okay, so one more time, if it's less than, they point in together. If it's greater, they point out. It's or. Okay.